This is my final video on the energetics, and it is on Hess's law. So Hess's law states that the enthalpy change of a reaction will always be the same regardless of the route taken. The enthalpy change of formation is the enthalpy change when 1 mole of substance is formed from its elements under standard conditions with all reactants and products in their standard states. The arrows for the cycle of the enthalpy of formation go up from the elements. Also, the enthalpy of combustion, well, the definition for this is the enthalpy change when 1 mole of substance is completely burned in oxygen under standard conditions with all reactants and products in their standard states. And the enthalpy of combustion cycle's arrows go downwards. So this will make more sense grammatically. So the formation cycle can be seen here, and as you can see, the arrows, which were in black originally, all went upwards from the elements. These all need to be balanced, so as you can see, we've got 1, 2, 3, 4 carbons, so then that's why I've got the 4 carbons here. And you can count the rest and see that they're all balanced. We need to make a cycle, so as you can see, I have switched these to go in the opposite direction, and as I've switched them, I've flipped the signs. So from negatives, they became positives. Something that you might as well be aware of is you never have a value for a formation of an element from an element, because logically that just won't make sense. So that's why the oxygen here has a value of 0. So putting all this as a cycle, we just add everything together, because obviously it's this, add this, add this, add this. And that's what I've done here, and you can see for yourself that this works. So moving on to the cycle for the enthalpy of combustion, well, here the arrows go downwards, as you can see here, and in this instance we never have a combustion for oxygen, because by definition you can't burn 1 mole of oxygen in oxygen. Logically that doesn't make sense. So it'll be the same principle where you just make a cycle. So in this case it's this one that's switched, and that's all you need to know for the Hess's cycles.